So let's look at question 2 again, work with quadratic equations that cannot be factored. So the two strategies they talk about is completing the square and also the quadratic formula. Notice how it says give exact solutions and simplify radicals and reduce. So there's a lot going on in these problems. So again, the first thing in completing the square is we have to isolate the quadratic term and the linear term. In other words, they got to be on the same side of the equation. So notice how the 8x squared is on one side, but the 16x is on the wrong side. So what I can do is move it over, but when I move it over, it changes signs. So the minus 16x is here. But notice that the constant's got to be on the other side of the equation. So I'm gonna give myself a little bit of space here. And that minus 24 has got to change over to the other side of the equation, and it's going to equal a 24 over here. So again, when you change sides of the equation, your sign changes. The next thing is you got to make the coefficient of the quadratic term equal to 1. So that tells me I have to divide everything by an 8. So I have to divide everything by an 8. So the 8's cancel out and give me x squared. 16 divided by 8 would be a minus 2x, my space there, and then 24 divided by 8 would be a 3. So we've got what we need here. Now, to complete the square, what we do is we take half of the negative 2. So what that means is divide by 2, if you will. So negative 2, let me see if I get this calculator to work. Take half of negative 2 divided by 2. It would be negative 1. But then we have to square it. So what I'm going to do is add a negative 1 squared here. And I'm also going to have to balance the equation, which means I have to add a negative 1 squared over here. But we know that negative 1 times negative 1 is actually a positive 1. So I'm going to go ahead and just change that to a 1 over here. Now, this becomes a perfect square. Notice how this is going to fit the format of if I have a squared minus 2ab plus b squared, that's going to factor into a minus b squared. So what we actually have here is our a is x and our b is actually this negative 1. So notice how we don't have to really think hard here. The x is the first piece. The minus sign tells me that I'm a minus. And what's squared here is my b. So what I do is I set up a set of parentheses, and I just put the x minus the 1 in, and that's going to now be a perfect square, because that's what complete the square does. And then 3 plus 1 becomes then a 4. Now from here, where it gets interesting is to get rid of a power 2, we have to take the square root of both sides. But also we got to remember that this could be a positive or negative. So when we drop the radical, this becomes x minus 1, we have to bring in a plus or minus symbol, and then the square root of 4 becomes a 2. So then to get x by itself, we just add a 1 to both sides, so we have 1 plus or minus 2. So this problem actually doesn't look all that hard. So that tells me that, well, 1 plus 2 would be 3, and 1 minus 2 would be negative 1. So that means that x has to be a 3, or let me use a comma there. I think they say separate by commas. So 3, comma, negative 1 would be your two solutions. So that's what complete the square looks like. Now the quadratic formula, the equation's got to be set equal to 0. So in this case, all I do is bring the 16x over to the other side. So let me write this down here. I have 8x squared. Oops. Let me make some room here. Oops. I went with it there. Come on here. Backspace, backspace. So there, come down. Set this so I can move. So if I'm going to use the quadratic formula, we're going to have this 8x squared minus 24 equals 16x. The 16x has got to come over to the same side, but notice how the linear term is in the middle. So 8x squared minus 16x minus 24 now equals 0. Now, notice that everything is divisible by 8, so I can go ahead and divide everything by 8 like we did up here. So I can make this a little bit easier and write this as x squared minus 2x minus 3 is equal to 0. And then I could use the quadratic formula. So a would equal 1, b would equal negative 2, and c would equal -3. So using the quadratic formula, it says take the opposite of b. So x is going to equal, the opposite of -2 is a +2, plus or minus the square root of, and then I have b squared. Well, -2 times -2 would be a 4, minus then 4 times a, which is 1, times c, which is -3. And then this is going to all be over 2 times a, or 2 times 1 would be 2. So it looks like the only math I need to really figure out is what's this 4, oops, minus 4 times 1 times -3. So it's going to give me a 16. So this is going to be x equals 2 plus or minus the square root of 16 over 2. But we do know that the square root of 16 is 4. So this becomes 2 plus or minus 4 over 2. So from this, I can say, well, 2 plus 4 divided by 2, 6 divided by 2 is equal to 3. That would be one of the answers. The other answer, I have to do 2 minus. So 2 minus 4 divided by 2, that's going to be -2 divided by 2, which is going to give me a -1. So again, my solution set again would be x equals this 3 and this -1. Now notice also, though, that if I look at this equation, x squared minus 3x, I'm sorry, minus 2x minus 3 is equal to 0. Notice that since the coefficient of x squared is 1, what I could have also done on this problem is see if it was actually factorable. What are the factors of a -3 that add up to -2? Well, notice that there's only a 1 and a 3. 1 times 3 does give me this 3, but notice how I need a -2, though. Looks like the bigger number's got to be negative. So notice that 1 times -3 does give me -3, and 1 plus -3 does give me -2. So actually, this problem is factorable. So I could say x plus 1 times x minus 3 is equal to 0. And then I could actually set each factor equal to 0. X plus 1 would have to equal 0, or x minus 3 would have to equal 0. So notice that x would equal -1, x would equal 3. So actually, the best strategy to this problem would have been to just simply factor it. But they asked us to do it by completing the square. But in the end, if we had other choices, my choice would have been just to simply factor it as opposed to complete the square or the quadratic formula.